In my previous videos, I have spoken about areas of science where, for the most part, everything has been worked out. Or, at the very least, there are a few solid theories just waiting on a bit more evidence. This is true for most aspects of science, however, there are a few small areas in which no reasonable theory has been presented. There's not two schools of thought or anything like that. In these few select areas, no one seems to have any answer to explain whatever the question may be. This is seen in most with the Big Bang theory. It's mostly agreed that before the Big Bang there was nothing, or everything, everywhere and nowhere, for all of time and ever. Simple enough. Although this seems a bit implausible, it is true. If there was no matter, no stuff, then there could not be a where, as where is where something is. And if there is nothing, then there can be no where. Still following me? Then there is the matter of when. Because time is not a constant as one would expect, time is completely dependent on mass and velocity. So if there is nothing, then there is no movement, so no velocity and still no mass, therefore no time. It is agreed that after a lot and a little of everything or nothing, there very much was everything. Everything stretched from everywhere, and it was all very hot. After that, physicists pretty much agree on what happened. Hydrogen formed, became massive clouds of gas that began to form stars, where heavier elements were forged. Those stars became supernova and formed the heaviest elements, then planets and more stars are formed from all of that, and so on and so on. The one hole in this theory, as far as I can tell, is where all of this matter came from. Some say that we were not the first universe and ours was born as a previous universe collapsed into a singularity. However, that would require the universe to start collapsing, and ours is still accelerating due to dark matter, and that's still somewhat of a grey area. So, assuming previous universes had the same laws of physics as we do, then it must have needed to collapse back, and we can't see how ours will with our current knowledge. But regardless as to whether we are the first universe or not is not the issue. At one point there was no matter at all, and somehow now there is matter, and a lot of it too. Where has it all come from? The first law of thermodynamics dictates that energy cannot be created or destroyed, only transferred. The same applies to matter, as matter and energy can be converted into one another thanks to Einstein's famous equation E = mc squared. Following this law, there should be no way that any matter or energy could be created, and yet, with the Big Bang, all matter and energy was created in an instant. Now, at this point, I would like to offer a couple of different opinions on the matter, a few theories, and hopefully explain some of the points made. However, this is one of those times where science does not seem to be able to provide an answer. So, your guess is as good as anyone else's. Therefore, instead, I'm just going to have to move on. So another time when current science seems unable to provide an answer is within the realms of quantum physics. Now, quantum physics is a relatively new area of study surrounding atoms and subatomic particles. It's widely agreed that it became its own area of physics thanks mostly to Albert Einstein in the early 1900s. There are many unanswered questions within quantum physics, and this is largely due to the fact that it is beyond human comprehension. It's easy enough to understand how things like electricity and momentum work, as we can see that happening every day. However, with quantum physics, things do not follow the same rules as they do in the larger world. As my old physics teacher once said, if you think you understand quantum physics, you do not understand quantum physics. Now that I've hopefully impressed you with how little we understand about this area, I'm going to talk about an experiment that has everyone stumped. It's called the double slit experiment, and it's used to prove that light must be a wave. As the name suggests, the experiment requires two slits in an opaque barrier, a source of light and a surface for the light to shine onto. Because light is a wave, When it is shone through the slits, they effectively become new sources of light, and the waves interfere with one another. As the peaks of waves meet, they will phase together to form a larger peak or brighter light, and where a peak and a trough meet, they will cancel out and leave no wave and a patch of darkness. When the light hits the surface at the end, it will make a pattern of light and dark stripes. This proves conclusively that light is a wave, as there is no way for particles to interact with one another as such. But it is also known that light is made of particles. So in the interest of fairness, physicists took the same experiment and replaced the light source with an atom gun as such. This would fire a stream of atoms at the first barrier, and the surface at the end would be replaced with a photosensitive material that would change colour once it's been impacted by an atom. The result that was expected was that there would be two lines of marks where the atoms had landed, much like you would expect if you rotated the whole thing downwards and poured sand through the slits. You'd get two piles of sand at the bottom, underneath the slits. However, the result was quite unexpected. After the atom gun had been firing for long enough, the pattern at the end was mostly the same dark light pattern strips that came with the wave experiment, with a few atoms landing in between. So it was suggested that perhaps the atoms were interfering with each other in some way, possibly bouncing off one another to leave this pattern. So the experiment was reset and the gun was recalibrated to only fire a single atom at a time, ensuring that there was no way for it to be affected by any other atoms being fired. The result, however, was exactly the same. Somehow, with only one atom in flight at any given moment, they still created this dark light pattern. This clearly needed to be investigated further, so a sensor was attached to one of the slits, and it was set to go off whenever an atom went through the slit. It could then be assumed that if it didn't go off, the atom had gone through the other slit. So with this new arrangement, the test was run again. Sure enough, 50% of the time the sensor went off. So half the atoms went through one slit and half the atoms went through the other. Here's what has physicists stumped. Despite the only change to the experiment being the addition of the sensor, the results changed significantly. Instead of the dark light pattern that had been seen in all the other experiments, there were now just two lines of light with the slits, as if the atoms had just gone through the slits in the same way sand would, as I mentioned earlier. So somehow it seemed that the mere presence of the sensor was interfering with atoms as they travelled through the slits. So in the interest of creating a fair experiment, the sensor was switched off, but left in place. The experiment was ran again, and the results went back to the original dark light pattern. So not only was the sensor interfering, it would only do so whilst it was switched on and recording data. It almost seems like the atoms knew when they were being observed, so behaved differently because of it. As far as I'm aware, nobody has been able to come up with an explanation for this using our current knowledge of the world and physics. Some have suggested that this is evidence of our universe being in a highly complex computer simulation, and as satisfying as that answer may be, I personally feel that it is a lazy answer. I say this only because if it became a mainstream theory, then scientific advancements may halt, as anything that can't be explained will be brushed off as a quirk of the simulation, instead of being investigated until an explanation is found. So if you can come up with any sort of solution to this problem that doesn't rely on a higher power, then please share it, as I'm sure you would win a Nobel Prize for your efforts. Do you know of any other aspects of science in which the current explanation is we don't know? If you do, drop a comment and let's see what everyone else thinks. As always, thank you for watching.